Okay, thanks, Michelle. Thanks for starting this first community Q&A. I think it's super useful for the Yugabyte community and super excited to talk about GraphQL. To get started with the session, GraphQL nowadays has become like the de facto API query engine, right? Like for UX developers. So GraphQL, in essence, what it does is back in 2012, 2013, when Facebook came out with GraphQL, they wanted to have UX developers like an ability to query their APIs and databases on the from the perspective of the UX developers. Previously, what used to happen is like as a UX developer, somebody would have come up with an API for them, and they would have queried that, and bunch of pre-processing and post-processing they would have to do on their app side, like whether it's a mobile app or whatever the edge app that they were doing, right? So in order to prevent that, GraphQL came into existence, where GraphQL provides a programmatic way of querying your APIs and databases without having to write much of the server-side code for the UI developers, right? Today, we are gonna see how we can get started with GraphQL on Kubernetes using Yugabyte database. So for our GraphQL engine, we are using Hasura GraphQL. So that's one of the popular GraphQL engines out there. It support Postgres compatibility. So since Yugabyte is a Postgres compatible database, we went along using Hasura for this demo. What we are going to do is we are going to first start off with like setting up the GraphQL engine itself, and then first the database itself and the GraphQL engine connecting the database, and we're going to do a bunch of GraphQL queries. So, and what YugabyteDB, right? Like, so in GraphQL, there's currently like most of the Hasura or any GraphQL which works against Postgres database, they work against like a single node Postgres database, right? It is kind of there's a bottleneck for scaling the single node Postgres SQL. So as and when you are scaling your GraphQL servers, it's like either the only way that you can do it is through like vertically scaling this Postgres SQL instances. Obviously, there is a limit to how you can do that, and also you have to think about how you do the HA fault tolerance of all your services using GraphQL. So in order to quickly like solve that scaling out problem and the HA problem, distributed SQL databases like YugabyteDB can help. So Yugabyte scales linearly through sharding the relational data, as well as it can be deployed across different multi-regions and zones, so that you can get a fault tolerance and high availability even when there is a data center outages or a cloud outage. So that's where Yugabyte comes into the picture. In today's session, we're going to just see how you can bootstrap a Hasura GraphQL engine with YugabyteDB. That's all I had for the presentation. I just wanted to spend a few more rest of the presentation on the demo itself. So what I have for this demo is these are the three things that we're going to do. We're going to deploy the Yugabyte cluster on Kubernetes. We're going to deploy Hasura on Kubernetes and create few tables from the Hasura console and execute few GraphQL queries, right? So what I have already done is I already have a Kubernetes cluster that I have provisioned. If you see, I believe I have 4-node Kubernetes cluster, and I'm using GKE for this. And along with that, what I have is I have deployed Yugabyte's platform console already on Kubernetes. So let me show you the UI for that. Get service. Okay, this is where my Yugabyte console is. Let me quickly go back and go there. So this is the Yugabyte platform, which allows me to create databases on the fly. This is like a DB as a service on your Kubernetes cluster on your public or private cloud. So right now, what I'm going to do is I don't have any clusters. I'm going to create a Yugabyte DB cluster. I'm going to call it GraphQL cluster, and I'm going to consider as one of the Kubernetes clusters that I've already configured to use. And I'm going to deploy it on US East. I'm going to have 3 nodes, which means it is going to be a 3-node Yugabyte DB cluster, which is going to shard the data on all these 3 available nodes. So since it's a demo, I'm going to just reduce the volume, and I'm going to go ahead and create the cluster. What this actually does is this goes and creates a Yugabyte stateful set on Kubernetes, and we can quickly check the pods coming up here. Get pods -n yb dev GraphQL cluster. So all of the Yugabyte DB clusters gets gets deployed in its own namespace, so that things are separated. Anybody who have access to that particular namespace, only they can access the cluster. So this is what the Yugabyte platform does. It's gonna take like a couple of minutes for it to come up. We can see the progress of the cluster also here. Once everything comes up, we'll see the cluster completion getting shown. Like it will show a green status here. So a few other things that we provide, like you can set up configs for multiple different clouds or multiple different Kubernetes provider or your on-premise data centers as part of the platform. And it also allows you to set up backup, security, a bunch of other things using the Yugabyte platform. So, okay, now we see that Yugabyte cluster is already ready. So what it actually provides is, like, if you can see, the Yugabyte clusters by default will have 2 masters and 3 T servers. So masters are nothing but like a coordination nodes. It doesn't hold the data. The T servers are the ones which actually hold the data. And if you see here, we also have we can also see all those pods running in the Kubernetes cluster. Now let me quickly go ahead and deploy the Hasura console and the Hasura GraphQL engine, right? So even that gets deployed as a Kubernetes stateful set. I'm gonna just say Kubernetes apply and Hasura deployment.yaml. So that's gonna go create a stateful set and a service, and it's pretty straightforward how you do it. You can go to Hasura and documentation and pretty much download this deployment YAML from there. So all you have to change is you have to change this Hasura GraphQL database URL where you specify the connection string for connecting to your cluster. This is the only change you would have to do. Rest of the things is pretty straightforward. All I'm doing is I'm gonna start a single node single node GraphQL Hasura GraphQL engine. So let me see if the pod came up. Once the pod comes up, we can go to the Hasura console to see the GraphQL client. Let's see, it says Hasura is running. Let me quickly get the load balancer, which is assigned to the Hasura console. Okay, this should quickly bring it up. Okay, quickly see what's happening. Okay, perfect. This is up. So this is the GraphQL, like the Hasura GraphQL console. This is where you can go ahead and create your GraphQL queries, as well as you can also make sure that you can create tables. And if you have made initialized Hasura GraphQL console on already existing schema in your database, then it will all show up here. All you have to do is just track all those tables. Since I don't have any tables created, I'll just go ahead and create a table here. So this is that's straightforward. Like all we did right now is just run 2 commands on Kubernetes. One to spin up my database itself, and the next is the GraphQL engine, so that I can run my queries and design my queries and things like that. So with just 2 steps, as an app developer, I can get started with GraphQL and YugabyteDB. So to quickly get started, I'll just create a couple of tables. One, let me call it as an author table, and it will have a couple of columns. So all I'm doing is I'm getting this data from the YugabyteDB docs that we have for GraphQL. I'm just running one of the demos from there. So I'm going to create ID, and I'm going to one more name, and make it a text, and I'll say ID is my primary key, and I'm going to say add table. So what this actually does is this goes ahead and creates a table in your database, and as well it starts tracking this author table, so that you can write GraphQL queries against this author table. So let me go ahead and add one more table, so that we can do some queries on relationships, like primary, foreign key, and aggregate, things like that. So let me call it an article table, where each author has a bunch of articles that he has written. I call it as an article table. I do it as ID, column, integer. I'll write one more called title. And for title, I'm going to make it a text. I have to content. I'm gonna make this a text as well, and I'm gonna have a rating, so that we can do some aggregates on this rating column. I'm gonna do it as an integer, and I'm gonna have a author ID, so that it can be used for a foreign key relationship for the author table. I'm gonna call it, I'm gonna make it an integer, since it was an integer in our primary table. So the primary key is gonna be ID. And one additional thing we're gonna do for this table is we're gonna add a foreign key relationship. We're gonna say it's gonna reference the author table from author ID to reference ID column in the other ID column in the author table. So I'm gonna just say save, and I'm gonna say add table. So even once this gets created, there's another thing that GraphQL shows up is if you go back to the data here, there's like there's a couple of foreign key relations that we already have defined, that gets defined by Hasura, which we need to track as well. So that this becomes available for our GraphQL queries. So okay, let me track both of them. Okay, perfect. I think now we have set up our schemas. And if I go to my GraphQL console, you should see that I have all the available columns and all the aggregations and order by rest of the things that we can do for a table already become available for the developer to start. So before I go ahead and start some GraphQL queries, let me go ahead and insert some data, right? So for that, I'm gonna use my dbeaver connection. Before that, let me see what the IP address, what's the server IP address that I need to be connecting to. So it is, again, Kubernetes construct. We are gonna enable a load balancer for our cluster. So it will be available in the same namespace that we saw before in the dev. And if you see, this is the server load balancer, which we'll use for connecting our DB clients, as well as connecting from our CLI clients, things like that. So let me go ahead and say edit this connection, so that I can connect to the new one. Postgres, everything looks good. By default, we use the Yugabyte database, and the username you can use Postgres or Yugabyte. We support both. quickly refresh this. Perfect. I'll just insert some data so that we can query some data through our GraphQL. Let me run this. Okay, perfect. The data got inserted. Let me quickly run these two to see that I'm getting. Okay, I have 2 records here. Perfect. Now let me go back to my GraphQL console so that I can query this data. So what I want to do is now I want to, like, let's say query. Let's say I want to get and all the articles that are available now on the database, right? I'll say I want the title, I want its rating, I want to know what it actually means. So that's it. If I all I with just this small query, what I'm doing is I'm trying to get all the articles that are available in my database. So since it's a small data set, we are not doing any patching or paginating here. Like even GraphQL supports paginating your queries, right? Now let's go ahead and create one more query, which is like slightly more involved. Let's say I want to list all the authors and all the articles they have written based on the ratings that they have got for each of those books, right? So let's say I want to create an author. I want to order by through the article aggregates. I want the aggregate to be an average of their ratings. And within author, I also want author's name. And within articles, let's just say I want to order by or order by rating, or order by, let's just say, a title. I'll do ascending of the title. And in articles, I want to probably have the title, content, and rating. So what this actually gives me is, like, as an app developer or a UX developer, I don't need to understand the schema of my tables, right? Like all I want to do is, like, in my app perspective, if whatever how I need the data to be represented for my on my app, that's all I care. So this is what I want my apps to get. So that's why I wrote this as a GraphQL query. And behind the scene, what GraphQL Engine does is GraphQL Engine converts this query into a bunch of SQL statements, which fires against the database. So all those things are kind of abstracted away from the UX developer. So I just run this query, and if you see here, I have 2 authors, Jane Doe, and Jane Doe has these titles, and now everything is like sorted out based on their rate. So with minimalistic code, you can get the data that you're looking for. So that's like the power of using GraphQL. So in order to use this GraphQL query in an API, let me quickly show you, like, through a Postman, how I can make this an API call. So let me bring my Postman out here. So Postman actually provides a way of firing GraphQL queries. I'll just get the GraphQL URL that I need to use here and just say a post. And in the body, I need to send a GraphQL query. So I'll just copy the GraphQL query we just created, and I'm gonna run this query. So as a UI app or a Node.js app, what we'll be doing is, a React app, we'll probably just making a using a GraphQL kind and making a call to this API with this GraphQL query, and I will be receiving this response. So with as we showed you guys, like, with minimalistic code, you can start querying your database. And also it is very straightforward for us to getting started if you have access to Kubernetes and a cloud native database like YugabyteDB, which works natively on Kubernetes. Perfect. Any questions till now? Probably this that's all I had as part of my demo as well. If you guys have any questions, I'm happy to answer.